Hello students. I have come again with few more questions from this chapter, electromagnetic induction. In the last class we discussed 3 questions, I think, from this chapter, basically from Faraday's law of electromagnetic induction and from motional EMF, right? So today we'll see few questions from self-inductance, mutual inductance and transformer, and the questions will be related to your board exam. Okay, so without wasting time we can start, right? So this is our first question, you all can see. So the first question is, a coil has self-inductance 0.5 Henry, okay, with magnitude, find the magnitude of EMF induced in it when current flowing through it is changing at the rate of 100 ampere per second. So this type of question is very easy, okay, just one direct formula is there, that is EMF equal to L di dt. Okay, I am not taking minus sign because minus sign will again tell about the direction, right? So only we have to find the magnitude, okay, find the magnitude. So magnitude निकालने के लिए माइनस साइन नहीं पुट करेंगे, ठीक है। तो इसके बाद क्या करेंगे, इसके बाद वैल्यू पुट कर दो। L कितना दिया हुआ है, 0.05 हेनरी. So 0.05 Henry is the SI unit, so no need to convert. And di dt is what? This is what? This is rate of change of current, right? A rate of change of current. This value is also given. A rate of change of current. This value is also given. How much? 100 ampere per second. Okay. So what will be the value? 0.05 into 100. So use calculator. 0.05 into 100, it will be how much? 5 EMF. This is EMF, so volt. Okay, so this is nothing more. This will be only 1 mark question. Okay, 1 mark question. Directly you use the formula, put the values and find the answer. Okay, so this is our first question. Let's check the answer. So answer is 5 volt. You all can see here, answer is how much? 5 volt. Okay, so go to the next question. So next question is, you all can see, an EMF of 3 volt induced in a coil when current in it is changed from 0 ampere to 10 ampere. Okay, this is what? Change in current. In how much second? 0.50 second. Find the coefficient of self-inductance. So same type of problem, just you have to find different quantity. So the formula is same, E equal to L di by dt. So here E is given, E is how much? 3 volt. We have to find L di, change in current, how much? 0 to 10. So 10 minus 0, we will take only the magnitude, by 0.50. So we have to find L equal to how much? 3 into, just do cross multiplication, 0.50 by 10 minus 0 means 10. So after that use calculator. So 3 into 0.50 by 10, so we are getting how much? 0.15. SI unit of self-inductance is Henry. Okay, so this much you have to do, this much. Okay, this one will also be 1 mark question. Okay, clear? Check the answer. What is the answer? 0.15 Henry. Okay, clear? Come to the next question. So our next question is, when the current flowing through a coil P decreases from 4 ampere to 0 ampere in 0.4 second, an EMF of 60 volt is induced across the terminals of an adjacent coil Q. So here 2 coils are there. Okay, this is suppose P coil and this is Q coil. In P coil current is changing 4 to 0. So in P coil current is changing 4 ampere to 0 ampere in 0.4 second, and for that reason what is happening? 60 volt EMF is induced here. So this kind of induction phenomena is known as what? It is known as mutual induction, and we will get mutual inductance. So that is the question, you have to find mutual inductance, right? So formula is again same, E equal to M di by dt. this EMF is in the Q coil, right? Q coil, EMF is in Q coil, but this change in current will be in other coil, that is P coil. So here we have to find mutual inductance. Okay, so M dIP dt 4 to 0. So we'll take magnitude. Magnitude means bigger minus smaller always, because the magnitude of EMF is given, and 0.4 second. Okay, so M will be what? M will be EMF. EMF is how much? 60 volt into 0.4 by 4. This much Henry. So again use calculator. 60 into 0.4 equal to by 4, you will get 6 Henry. 6 Henry. Okay, so you don't have to do all these things, just this part. This is the thing you will do in exam. Okay, this thing I have shown what is the thing happening here. Okay, and the mutual inductance is how much? 6 Henry. Okay, this one will also be 1 mark. 1 mark you can think. Okay, 1 mark. So let's check the answer. Let's check the answer. Answer is 6 Henry, right? Answer is 6 Henry. Clear? Clear? Come to the next question. Yes, our next question is from transformer. From transformer. Transformer has 400 turns in primary coil and 1200 turns in secondary coil. So first of all, in this type of problem, we'll write the quantities. So we basically use NS and NP. NS is number of turns in secondary and NP is the number of turns in primary. In primary it is 400, in secondary it is 1200, right? 1200. And primary voltage is given. Primary voltage means VP is given 200 volt. Okay, and load in the secondary resistance is given. Secondary resistance is given 100 ohm. We have to calculate current in primary, not in secondary. We have to calculate current in primary, and it is given the transformer is ideal. Okay, so what to do? Primary current means if we know the secondary current, we can find primary current. Okay, so first of all we will find secondary voltage. Voltage we know directly related to number of turns. So Vs by Vp equal to Ns by Np. Okay, so Ns means 1200 by 400, you will get 3. We have to find Vs. Vs will be 3 Vp. 3 Vp means 200, so it will be 600. 3 into 200, 600 volt. Okay, so we got secondary voltage. Now secondary resistance is given, so we can find secondary current, right? Secondary current, I secondary, that is V secondary by R secondary. So V secondary is 600, R secondary is 100, so answer will be 6 ampere. Okay, but we have to find what? We have to find primary current. Primary current and number of turns, they are also related, but they are related inversely. Okay, कैसे related है? Inversely related है. So we can write IS by IP equal to, इस टाइम क्या होगा? NP by NS. Inversely related, NP by NS. Now NP कितना है? 400. NS कितना है? 1200. So it will be 1 by 3 now. क्या चाहिए क्वेश्चन में? क्या चाहिए? प्राइमरी करंट, दैट मीन्स IP. So IP equal to what? Cross multiplication, IP into 1 and IS into 3, right? Cross multiplication, that means 3IS. 3IS, that means 3 into 6, that means how much? 18 ampere. So what will be the answer? Answer will be 18 ampere. Clear? So this type of question you can think how much? 2 marks. 2 marks you can think. Okay, 2 marks. So this is the answer, 18 ampere. So how to do? First, voltage and number of turns, they are related. From there, using this formula, find required voltage, what is not there. Then come to current equation. Okay, you can find current. After that, current and number of turns, they are also related. Okay, they are inversely related. Current and number of turns inversely related. Okay, and voltage and number of turns directly related. Okay, so these are the things you have to practice. Okay, so I'm ending here, everyone. Again, in the next day we will meet with few more questions, this time from next chapter, that is alternating current. Okay, so thank you everyone.